Okay, previously when we were doing the u substitution, I noted that the u substitution is how you reverse the chain rule. So if a problem required you to use the chain rule to take the derivative, you would need the u substitution to find the antiderivative. Now what we want to look at is how would you find the antiderivative of a function that required the product rule. So integration by parts reverses the product rule. Okay, so I want to start with the function u of x, v of x, and I'm going to take its derivative. So I want the derivative of u of x, v of x with respect to x. Well, product rule says that'll be u of x times v prime of x plus v of x times u prime of x. Okay, now let's integrate both sides. Okay, so I'm going to rewrite this. The antiderivative of the left side and I'm going to have u of x, v prime of x, dx, plus the integral of v of x, u prime of x, dx. Okay. Now, the antiderivative of the derivative of u of x, v of x, so I could have dx, will just be u of x, v of x, since that's just the integral of the derivative. And now on the right side, v prime of x dx is just dv. U prime of x dx is just du. So now just to simplify the notation here, I've got u of x v of x equal to the integral of u of x dv, or simply just u dv, plus the integral of v of x du, or just v du. And that's equal to just u times v. Okay, so now what I've got, I'm going to take this and I'm going to solve it for the integral of u dv, because we're going to be given an integral and then had to apply a rule to find the antiderivative. So I'm going to solve for this integral of u dv, which will be u times v minus the integral of v du. Okay, so what we're going to do is we're going to use this formula called integration by parts. We're going to be given a problem, and we're going to see if it matches this form. We're going to determine what our u would be and figure out what our dv would be, and then use those values to rewrite it in this other form and see if we can figure out what the antiderivative of that would be. Okay, so here's your formula. U and v are both differentiable functions, and the integral of u dv is equal to uv minus the integral of v du. So let's see how we choose those u's and dv's. Okay. In this problem, I see a product. A lot of times you're going to have a product for the integrand when you're going to be using integration by parts. So we've got to figure out then, how can I rewrite this so that it's in that form of the integration by parts formula? So we want the integral of u dv to be equal to uv minus the integral of v du. Okay, so you've got to figure out what your u is going to be and what your dv is going to be. And everything there has to be part of the u or part of the dv. Now, suggestion on this, a lot of times if you have powers of x, they make really good choices for the u. So choose those if you're trying to figure out your u in most cases. dv needs to be something you can integrate, because if you look at this, you're going to choose the u and dv based on what you're given, and then you're going to have to use u and v on the other side. So if you're starting with u, notice I'm also going to have a du over here. So if I choose a u, it's easy to get the derivative of almost anything now. But if I start with a dv on the left side, I've got to be able to come up with the v on the right side. So choose your dv to be something you can integrate. So dv should be something easy to integrate. Okay, so now in this problem, I'm going to choose my u to be the x, since it's a power of the x, and I'm going to choose my dv to be everything else, which would be the e to the x dx. Now to apply the formula, though, I've got to figure out what my v and my du will be, since I've got to plug those in on the right side. So if u is x, du will be just the derivative of x, which is 1 dx. If dv is the integral is e to the x dx, then that means if I integrate both sides, I'll have that v is equal to, all I'm doing is I'm integrating both sides. The antiderivative of e to the x is just e to the x. Okay, so now let's just plug it in. I know that this has to be equal to u times v minus the integral of v times du. So now plugging in my u, which was x, my v, which is e to the x, minus the integral of v, which is e to the x, times the du, which du is just equal to dx. Okay, so what we just did was we've just turned this integral, x e to the x, into a problem with a simpler integral. We can get the integral of e to the x really easily. So this will just be x e to the x minus the antiderivative of e to the x, which is just e to the x, and then we always need that plus c. And so we just did our first integration by parts. So now, what that tells me is that this function, if I were to take the derivative of it, would require the product rule, and it better give me x e to the x. We just reversed the differentiation. So let's check this one. If I were taking the derivative of this, I've used the product rule since it's two functions of x multiplied together. So I would have the first one times the derivative of the second, and the derivative of e to the x is e to the x, plus the second one, which is e to the x, times the derivative of the first, which is just 1. So that's just the derivative of x e to the x by the product rule. And now minus the derivative of e to the x here is e to the x, and plus the derivative of the constant is 0. So I've got x e to the x plus e to the x minus e to the x plus 0. These cancel. We get x e to the x left. Okay? So that's the integration by parts. Okay, now let's look at this one. Again, I've got that x times sine of x. It's a hint to use integration by parts when you see a product here. Remember, there's no product rule in integration, but to reverse it, you use the integration by parts. So now, I've got to choose my uv. This needs to resemble u dv, because if I get that, then I'm going to have uv minus the integral of v du. Okay, so now, x sine of x. Let's go ahead and pick our u to be our x again, and that would leave our dv to be everything else, which is sine of x dx. Just make sure you can integrate the dv. Okay, if u is x, that means your du is just dx, and if dv is sine x dx, that means that the v is just going to be negative cosine of x. Okay, so now, if you took the derivative of cosine, it would be negative sine, so that's why I need that extra negative there to give me the sine of x for the derivative. Okay, so now, plug in the parts. The u here is just x. The v will be negative cosine of x. I'm putting in parentheses so you don't think it's a subtraction. And then minus the integral of the v, which is a negative cosine of x. And then the du, which is just dx. So now I've got negative x cosine of x plus the integral of cosine of x. And the integral of cosine of x is just sine of x. So I've got minus x cosine of x plus sine of x. And now we'll put our plus c, and this came out to be the integral of x sine of x. So now if I want to check it, I would need to take the derivative of this side and make sure it came out to be x sine of x. So the derivative would be the first term times the derivative of the second, which is negative sine of x, plus the second term, cosine of x, times the derivative of the first, which is negative 1, and then plus the derivative of sine of x is cosine of x, and then the derivative of c is 0. So you'll see that the minus 1 cosine x cancels with the cosine x. I end up with just an x sine of x, which is what we started with over here in the integrand.